quality? What is meant by quality? Do you have any idea about quality?
Good product without bugs and issues.
Okay. Yeah. Software quality is like it's a reliable, it's a maintainability and usability, user-friendly product. And the definition of IEEE definition, IEEE saying like a software quality is meeting customers' expectation, not for the very first time, it's for the every time. Meeting customer expectation, customer needs, for not for the first time, for the every time. So in a software organization, how ensure or how we make sure that our software has a quality, we delivering a quality software to our customers. How we ensure that? That in our topic we discussed about various things and our various quality models and all, to make sure that we delivering a proper good quality software product to our customers. This is a this is a quality software quality model. In software quality, we have to, it's not only a job for it's not only a developers or a technical task. It's a combination of both technical and managerial activities. So software delivering or software development is a combination of process plus management activity. So it's a process oriented plus project management oriented. So process means process having we have a target, we have various evaluation methods, and we have a lot of processes. And in project we have working with in project management we are working with cost, effort, and our time. These all are working together to attain a good quality software. So let us start with our quality model. Like in a software organization, we investing lot of money. We investing lot of money to ensure a quality product, to build a quality product. Because in software quality assurance, we have different set of cost included in software quality assurance process. The total cost of the software developing is a sum of failure cost, appraisal cost, and prevention cost. Failure cost means if anything, you all know, if any bug arises or any activities or resolving bugs, fixing bugs, we need a cost. And prevention and appraisal cost, it's related to we providing training to our customer, our developers, our QA engineers. We investing a lot of tools for maintaining all this, maintaining our quality and all. So it's a collection of activities. It's a collection of activities, and at last we ensure that we delivering a quality product to our end customers. And here we focusing on, in software testing, we focusing on V model of software testing approach and V model of software testing methodology here. In V model of software testing methodology, as I said, like a good practice, in V model of software testing methodology, we have a V-shaped circle, V-shaped diagram, and in left side of the left side happening the developmental process, and the corresponding right side we have the testing phases, testing process, because in we have requirement analysis, the corresponding right side we have UAT, user acceptance testing, carried out there. So we have starting from the low level design and requirement starting from requirement analysis, coding, testing, implementation. The same part is like unit testing, integration testing, system testing, and at last user acceptance testing, and it's delivered to the customer. So a good practice for that, it's a continuous process of software testing. It's a continuous process. So we developing a single module or a single task, and this task is moved to the QA, and QA testing that that single application or single feature, and it's a we are go for the integration of 2 or more modules or 2 or more features combined together, and we are testing an integration test, and we are performing our functionality test and UAT, that is a user acceptance testing, and then it go for the production. So it's happening is a continuous process. It's happening in a continuous process way. So here is a quality is a collective responsibility of all who working in a software organization, whether it's a developer, it's a QA person, or it's a designer or project lead or a project manager. It's a collective responsibility to ensure a software product, a software's quality, because we are starting the process with a kickoff meeting, like a project starting from a kickoff meeting, and in our kickoff meeting we planning or we defining our project objectives in that meeting. In that meeting we defining our project or product objectives, what we deliver to the customer. What we deliver to the customer at that phase, we defining all our objectives, and we devise a plan how to do this, and what are the who all are participating in this team. We have defining a team structure, like we have a project POC over there, and we have a QA person, or we have developers, and we have a set of people working for that particular project. And in that project we have some milestones, and we define for each we now currently we are following agile methodology, a scrum based or kanban based process. In agile based or kanban based process, we have a sprint based release pattern we are following. In a sprint based release pattern, we have a feature. That feature we developed first, then it's moved to the tester side. The tester tested the application. If it's any bugs or something, it's back to the developer side, they fix it, and it's processed at the end. This feature or this particular project delivered to the customer side for UAT, and after it's passing the UAT, it's delivered to the customer side. So this is a simple process. In this process, we applying lot of processes or lot of quality assurance techniques to this. While we applying lot of quality techniques principles over here, first our technique, currently we are or nowadays we are following the techniques like exploratory or ad hoc based testing. In exploratory based technique or exploratory based testing, in exploratory, first we researching or we investigating what the project is. What the project is, what kind of project is we are dealing with. And in this project, we determining the test cases first. We determining the test cases, and we preparing the test data against our requirements. And this test data, we are starting the execution of this particular test cases. And in testing QA side, we defining the bug taxonomy, like a bug classification, and we have a QA tracker or tracer over there. The QA tracer, it's dealing with QA tracer, said like what we are testing, what items we are tested, what's our approach, and how we tested. Is it a manual process, or we doing any automated testing, or we are doing any performance related testing. These kind of activities in QA tracer or test tracer we are tracking, and we are executing the test. Executing this test in a ad hoc testing level. Ad hoc means we are repeatedly prepare the test data, and this test data we are applying into the system more frequently, and more frequently it applying to the system, and we identify that or we make sure that how the system is performs or how the system is responding to our test data, and we getting the result, and we are comparing the results, comparing the test results, and we find that our application is how our application is performed, whether it's a good application. So the advantage is for this type of exploratory testing is like the main advantage is like we don't have really a good software specifications, or we have a proper documentation, but we are applying our true set of or our defined set of test data into the system iteratively and more frequently into the application, and we analyze that how the system responds or how the system behaves, and we find that okay, this system is working properly, or the system is responding to the to our requirement properly, and we find that okay, this application is working good or not. And also we can identify that this identify or we can measure that the performance of the particular application, our performance of the particular application. So in the performance side also, at the very beginning of the application, mainly in software testing approach, we conducting performance testing after the regression phase. But nowadays we all know that in performance is really a headache to the organization or the developers or the developing community. So at the beginning stage, we defining or we setting our performance goals and performance activities. So at the very beginning stage, we can start with the performance related, whether our queries are structured or not, we having a well defined data structure or database structure or not. All these kind of activities we can make sure at the very beginning of the application. So we can deliver a good quality software. So in a collective responsibility side, we provide a holistic view of the application. Means a holistic view means everyone in the team have a clear idea about the application, clear idea about the domain. So first we have a workflow. We have a kickoff meeting kickoff meeting for our application. In that phase, who is responsible for the project POC is explaining the things using any diagrams or a simple workflow. He or she defining to every member to the team and explain all the things. So everyone get a clear idea about how the project is working on and what are the things we are need to cover, what are our risks, is there any technical challenges included in this project. These kind of activities we are measuring at this phase. And the second, we have exploratory that already I explained, and any specialized testing we needed like security or performance or that kind of, and create that nasty test cases. Nasty test cases mean invalid test cases or negative test cases we determining or we creating, and these test cases applying to the system directly, and we identify that how the system responds to these kind of test cases. And the next addition to this, develop a code first approach or well defined unit testing, and write integration, proper integration testing, practice a continuous integration, create and maintain the automation layer, and doing some testing sessions like how to ensure a high quality in our software application or in our software project. So it's a good practices like we are doing, or every organization have their own quality standards and quality processes, quality methodologies they are following, and in every organization they have a DevOps approach, like a continuous integration and continuous deployment and continuous delivery pattern. If we are following a continuous integration and continuous deployment, in continuous integration process, very quickly the testers can test the application. When a feature is developed and it's integrated and it's merged to the QA branch, or it's released to the QA people for testing, so they can easily, or they can quickly identify the defects or identify the bugs, and the developer at the very first time, very early, the developers can start the fixing the bug, or can work on that particular bugs. So it's very early. So continuous integration process make the software development more early and more repeated. We can avoid repeated tasks. So it's integrated very fast and quickly. So we get the application very fast, and we can report it if any bugs there. We can repeat it very quickly. And delivering fast with quality. In this session, we test early, test often, and test everywhere, and automate what we can. Everything we can automate. Like test early means at the said like if the feature, a single feature is ready, then the QA team start testing on that. So before that, in a discussion phase, that a requirement gathering phase, or the early coding stages, the QA team started the test scenario preparations, test cases preparation, so they can easily start the test execution when the feature is ready for testing. So they can at the early stage they can report if any bug is there, so the developer can fix the bug quickly. And then test often. Test often means for a feature wise system level of testing, and we have integration level of testing, more area we need to test, because our test coverage, we need to improve or increase our test coverages. So we define lot of scenarios and lot of test coverages in our application. We need to ensure that we at least we have to make sure that we have a 100% test coverage. So for every application, we need to keep a traceability matrix. A traceability matrix, for keeping a traceability matrix, we have a clear picture about all our requirements are properly tested using proper test cases. So we can ensure that proper test coverage is there or not. So this kind of activities helping to deliver a quality software and automate everything. We have in our regression, we need to automate our regression testing process, our API testing process, and our performance based testing process, automate everything. So we can quickly we can complete our process, or if any regression, we don't waste our time. We can use open source like Selenium or any other any other tools to automate a regression automation. So we can save a lot of time for the repeated task. And a simple approach. This is a puzzle, and this has a simple approach to the software tester, because in a software tester, how he or she approaching a problem or a task. If in this puzzle there are eight batteries, but only 4 of them work, you have to use them for a flashlight which needs only 2 working batteries. To guarantee that the flashlight is turned on, what is the minimum number of battery pairs you need to test? This is a simple puzzle. And what approach we design or we develop to resolve this? What approach? Only how we can start and how we can process. what approach to how we are approaching this kind of or what analysis we made. For a system like this, we need to first we start with a numbering 1 to 8 or A to F, that kind of numbering we get done. And next is we go for a circular path of testing, like a combination like 1, 2, 3, 4, that kind of a circular combination. So how a tester is approaching an application or how a tester is approaching a task, that is really we need to improve our skills or improve our perspective, how we looking into an application. We need to design or we need to develop more scenarios frequently, then only we can cover all the aspects of an application, So in a Notepad, if we are taking an application like Notepad, in Notepad, what are the test scenarios? We all are using Notepad. So what are the test scenarios in Notepad? If suppose we testing a Notepad application, what are the scenarios we are trying to test? Test cases or test scenarios, like we are open run and type on Notepad, click enter, then Notepad is coming and the cursor is blinking at the starting position and default word drop is on, and if we are typing anything, any text, it's greater than the horizontal bar, then the horizontal bar is appear like the vertical bar. That kind of testing scenarios or test cases we need to generate for a application, for any application. We need to analyze that this kind of approach we need to develop. So we can approach in an application and applying more frequently, we can apply more scenarios, so we can ensure that this application is working perfectly or not. And the next we are going to how to do continuous improvement. Continuous improvement is a process. It's a cyclic process. Continuous improvement. We making continuous improvement. First we need to describe, or first we need to identify what are the issues. Then we need to resolve the issues, and we identify what the root cause is, and we need to do proper follow up. So first we identify what the root cause is, and we need to explain all those things, and we need to resolve the things according to our investigation. We need to resolve the things and do proper follow up for that. For this we are we are following or in every organization or in IEEE stating that we deriving a plan like PDCA cycle. Like PDCA means it's a Deming. It's called as a Deming cycle or circle or wheel. It's simply a PDCA, like a plan, do, check and action. Plan, do, check, action. In the plan, the software development we are defining or we are planning software development methodology and defining our requirements and prioritize these requirements, and in do section we build and test a solution, and in check the software meets the initial requirements defined in step A, and in action roll out a solution or begin a new software development iteration until requirements defined in step A are met. In PDCA, simply we can take one by one. In planning session, software development methodology. we planning what software development methodology we are following in this particular project or this particular application, and defining our requirements and prioritizing these requirements. And in do section, we are executing this. The first is planning, and as per the plan, we are executing the steps, and then checking. After executing, we are analyzing what the results, and we are comparing the results. And at last, if there is after the comparison or analyzing the results, if anything, any defect or bug or any errors we found, we are take up action. That's an action. The cleanup action is taking place there. This is a complete repeated process. It's a cyclic process. This process is cyclic, and it's continuously it's working in an organization. So in an organization applying this PDCA cycle, then that organization is make sure that the application is continuously we are improving, and we are showing continuous improvement in the in our software development cycle, or in our software development methodologies. And in how to iterate software rapidly, here is coming code review, refactoring in sense of readability and usability of the software of the code, and modeling. Modeling means it's communicating with our developers or our QA persons with simple diagrams or simple workflows. And in code review section, we have an open discussion of the code. If a developer designing a particular task or a particular feature, he explained the code to the entire team members. So the entire team members can what are the approaches we are following, or how it's developing, and what are the methodologies we are following, or what are the techniques behind that. This kind of knowledge will get every team members. But in our testers or our designers or any other people, they are not aware of what the technology is, or what the approach, or what the technical terms are working there. But a programmer, he is explaining his code to the entire team and discussing, then everyone will get okay, this part is working like this. So this kind of approach we can we will do for the testing. So that kind of a positive approach or positive discussions are happening over there. So a open discussion with code based. So here code reviews, peer reviews, all that kind of reviews are happening there. And refactoring section. Refactoring after the reviews, if there is any refactoring is needed for readability and usability, or user friendliness, user experience improvement, that kind of refactoring is working over there. And the modeling. Modeling means we need to develop a proto before we develop the actual software. It's a simple design or simple workflow. So everyone will get a clear idea about, okay, it is like this. So we have a good healthy discussions about that, and how to improve, so we can compare if any other product is in the market, the same product is in the market, how we can compete with that with that product. These kind of healthy discussions are happening there. Otherwise, it's a simple process. A programmer or a team is simply sitting anywhere and coding, and at last the build is ready or the application is ready. It's hand over to the QA people. They are testing. They all are in isolated, or all are working as an island. But it's a group activity. So it's a team activity. So all are responsible for the quality. So all are responsible for the quality. In Boyer is a well-known developer in Microsoft technologies. He's joined in Microsoft as a trainee. At that time, his project manager told him, asked him about who is responsible for quality. Then Boyer said, yeah, it's a responsibility of the QA people, the quality testing people. But the project manager explained some scenarios to Boyer, and after 2-3 years, Boyer write a blog like it's the responsibility of everyone. As his experience on his understanding, like the software quality is the responsibility of everyone. So everyone inside the team is working as a single team. So healthy discussions and what's happening in the project, what are the risks we are facing. We have either it's a people risk if anyone immediately quitting from our team or quitting from the organization, then how we overcome that. If we have any technical risk, because yeah, if it's some integrations like some tally based or some accounting software based integration we needed, but we don't know how to do this. So these kind of technical risk we are facing. So how we overcome this or how we mitigate this? These kind of good healthy discussions happening inside a team. So everybody treated as a single yeah, we all are working for a single goal. So we all are a single team. So software quality responsibility is team's responsibility. It's not only the fault of the developers, not only fault of the QA person or any project managers. No, it's a total responsibility. And the next is like value driven or test driven. Which one is more higher or more valuable, test driven or value driven? Test driven, but then what about value driven? In the last 80s to 90s, Japan introduced a quality management principle that is called as TQM, total quality management. TQM, before TQM, we are product centric. Our development or our activities are product centric. We all working for a product. And after implementing this TQM, our approaches are changed, our thoughts are changed, and we are a customer centric, not product centric. Our views changed to customer centric because customer is the master. So IEEE changed their definition to quality is meeting the requirements, not only meeting the requirements, it's users needs, meeting user needs plus expectations. It's not only meeting the requirements, it's every user purchasing a product, either it's a software product or any hardware or any product, have some expectations, have some needs and expectations. So we need to make sure or we need to ensure the quality for that particular expectations. So we also work for that expectation also. So value driven or test driven, the more from my perspective, it's more advantage goes to the value driven because we are doing in test driven the biggest this is the biggest point of discussion. In test driven, don't care much about the output. The only thing needed is to carry out the test in a particular way. They only focusing the test is carried out or not. That only they are focusing about the test, how the test is carried out or not. And in value driven, we can take an example of behavior driven development, that is BDD, behavior driven development. In value driven, if we are following BDD, then it's not bother about don't mind how come up with the output, only that the output has to be correct under the given condition. If we are giving a condition, then what's the output is? It's always looking the output of the application. So exploratory testing is more efficient in BDD. So this is we are giving inputs, various inputs, and analyze, or we are analyzing how the system is responded to that particular. And if we are following a behavioral driven development, it's a collaborate and records features plus scenarios, fast fail features as to source code, build a continuous integration, run failing test, implement automated steps, run passing test, notify business plus releases. This is behavior driven. In behavior driven, we are writing the scenarios first, and that is first we writing the background of a particular feature. We are designing a background for a particular feature, and we developing a scenario outline for that. Then we are designing the feature, and in this feature plus these scenarios we are running this, and we are defactoring the result. That we are comparing more scenarios we are running and defactoring this result. Refactoring means we are comparing those scenarios results and find that whether the system is working. So in BDD, we are after this BDD process, these scenarios and these features, we can ensure that our application is working perfectly, or application is responding perfectly to the our given condition. Because our condition is like A plus B equal to C, then we can ensure that at least our system is delivering the particular condition, it's working perfectly. Okay. And in BDD automation, we can do Cucumber, Selenium Cucumber, using Selenium Cucumber. In BDD automation, we are using a simple language using Jenkins. In BDD, write stories and acceptance criteria before the sprint start. Before the sprint start, we are writing stories and acceptance criteria, and commit these stories to the sprint. They commit for a particular sprint, and during the sprint we developing these stories and writing the test scenarios using Jenkins, and run the test, and we run both manual and automated test. In this BDD automation, we can define our scenarios in simple language, simple English language, so everyone can understand that our business people, so our business executives, business analysts, product owner, everyone can get a clear picture about how these scenarios are working, and if any additions needed, they can easily contribute to this. So we are linking our test data to a Excel or Excel or CSV sheet, so they can change the test sample inputs from there more frequently, and they can see how the application is responding to the to our giving input. So this kind of behavioral driven development is nowadays more popular in the software testing phases. So we can adopt these kind of good practices in our organization. So we can ensure that we deliver a high quality software to, or high quality product to our customers. So we need to think that alignment or that perspective. So we need to change our approaches. So the way we address ourselves, that QA or testers and developers, need to be changed. It should be all about the team. We are here to mutually help each other to deliver a high quality software. That's our aim. Our objective is to deliver a good quality software to the client. So, one team, and we have a one single goal, and some best practices and some best recommendations are there. First is check every path of your code once. Code reviewing, code refactoring, or unit test coverage. We need to improve the unit test coverage. That's a vital part in the software development activities. And the second is always write code to handle null value parameters in the functions. And third is always perform correctness testing of your work when you update the code from repository, and use unit testing to automate correctness of testing. And next one, if you can't test all the corner cases due to time constraint, don't be shy to inform your QA about this. If we are not covering the entire scenarios, it's open to the team. Yeah, we are not covering these portions. We are not executing these test cases or these scenarios. So everyone get a clear idea about that. Okay, this part is not tested. It's a open. Openness is more important in a team activity. So everyone can help mutually. And the next is executing one cycle of test case and make it pass before handing over to the testers, and automate as much we can. And automate everything means automate. It's a first time the investment for automation is little high, but the output or the result is imaginary. And yeah, it's giving a lot of improvements. It's making a lot of improvements in our process, and it give a lot of opportunities to our application. So we are automating our regressions or our performance or our security. So we will get a good quality software. And any questions? ID we are using Eclipse. And we can use JetBrains IDE also, but here we are using Eclipse. Okay, and thank you.